Melbourne. I'm a lean software developer based in the West Country. I love Perl, and I love Perl 6. I want to tell you why I like it. I want to share with you the joy of 6, what I think the joy of 6 is. But I want to make a confession first. I've got a bit of a habit. Late at night after I put my kids to bed, I find myself going onto the IRC logs. And I have done for about 10 years. This is the IRC logs of L6. And in there you'll find a blow-by-blow description of the technical dragons that have been taken on over the 10-year, 15-year development of L6. So in here I've noticed lots of different things, and I want to share with you what I think is the joy of 6. Not to be confused with the joy of 6, although there are some similarities between the Perl 6 development process and what they talk about in this book. One of the similarities was playful experimentation was encouraged. Another similarity, fumbling around in the dark, encouraged. Interesting new discoveries were made during this process. Also, moaning is supposed to actually be a good sign when moaning gets louder and louder. And over the Perl 6 process, there was plenty of that. So we must have been heading in the right direction.
What about playing 2 languages at the same time?
So what is the real joy of 6? Well, one part of it is, actually it's Christmas. It's this Christmas. After 15 years of genesis, design and development, we've actually got to the point where we're saying that this is production ready. And so that's actually an achievement. And I think we should actually just stop and be happy. That's a technical achievement. Let's appreciate that. It's Christmas. But what's going to happen the day after Christmas? You've opened your new toy, you've played with it, it's Boxing Day. What's going to be the enduring joy of Perl 6? And that's actually what I'd like to talk today about. So I think the enduring joy of Perl 6 has got something to do with what's going through Federer's head at the moment. I don't know, I can't read his mind, but I can imagine what could be going through his head. He's sitting there in a problem space, and problems are firing at him at 100 miles an hour. And he's there providing solutions, learning as each problem comes, and there's this very exquisite match between his ability and the challenge that's facing him. And often you see this sort of kind of oscillate over the course of the match. So that mental state, I think, is what he's in the zone, or he's in flow. Hands up if you've ever had this experience of flow while you're programming. I get it a lot when I program in Perl, and I hope that I'm going to get it more when I'm programming in Perl 6. You don't have to be a Federer to feel flow. Actually, kids feel flow all the time. But young children, it's amazing what they can do when they're in flow. They just are effectively learning. They're little learning machines, picking up new skills and abilities as they're playing. So this is actually sort of the graph of what flow is, an explanation of it. Flow is a sort of sweet spot in the middle, where you match your ability and challenge, where your ability basically matches the challenge. You can sort of stay in the zone. And when you're learning something new, you often sort of bump along this top part, as it's kind of a bit stressful. Oh, why doesn't that work? Oh, that's why it doesn't work. Cool. I'll learn that now. So Perl 6 has had this idea from the very beginning of its implementation. And Audrey Tang came into the channel in 2005. She set the channel up in 2005 in the IRC channel and said, actually, Perl 6 is optimised for fun. So what does she mean, optimised for fun? What kind of language is optimised for fun? Is this serious? Is this a serious language? Is this a serious suggestion that we should have a language that's optimised for fun? Well, she invited people in, and her idea of fun was to implement Perl 6 in Pascal, which for me is way up there on the ability scale and a bit of a challenge. But nonetheless, she went for it, and she got quite a way along the track. Developed a test suite, developed an initial implementation hubs in Pascal. And there's been some enduring things that she's left behind. One is this meme of optimise for fun. The other thing is the test suite that has now grown to over 50,000 tests. And the idea that Perl 6, whatever passes that test suite, can be called Perl 6. So actually flow is a really precarious sort of mental state. You can go in and out of flow quite easily. If someone interrupts you, the manager comes and taps you on the shoulder to say you're not being agile enough. That's a bit of a flow stopper. So actually the psychology of the IRC channel is really important to welcome people in, to invite them to have fun. And one way she did this was to say, well, actually, she really gave out commit bits. And said, well, just go for it, we'll forgive you, you don't need to ask for our permission. So it's an invitation for people to come into the channel to pick out of the problem space all the various challenges that are on offer, to pick, given their level of ability, the appropriate amount of fun that they were going to have on that spectrum. And lots of people came to make contributions. Here are the top 30 committees over the last 15 years across Perl 6 projects. And of course there's many more than people on this list, but this is just the top 30. And you can see that there are thousands of commits across lots of different projects. Another important way of generating flow is to mark progress, so that people are feeling like actually things are getting done, they're actually going somewhere. And karma in the channel is one way that was done. So the karma block, every time you make a commit, karma block gives you a bit of karma on the channel. And it's just a small thing, but it's basically saying psychologically, yeah, we're making progress. Despite maybe some of the negativity that's coming from outside the channel, we are positively making progress here and chipping away at a very large problem. And here are Jonathan's commits since 2005 or 2006. And you can see this is a man in flow. And that's a fantastic thing. You can see that actually Perl 6 isn't just one project, it's an amalgam of other sub-projects that all sort of come together as a foundation for this sort of bootstrap the language. It all comes together basically. So just like with that child in flow in the first slide, actually flow is about learning. It's about your ability improving, taking on more and more challenge, and you learning as you go, and feeling progress as you do that. Here's Jonathan just recognising his own learning as he's moving through those different challenges. Now I know Amelia could be a bit controversial, but I actually think she's really important for flow in Perl 6. Only yesterday, she guarded the channel against a troll that came in to say, this isn't a professional logo, I'm a professional programmer. Why would I program in a language that's got a logo like that? I'm a professional. You're offending my sense of professionalism. What was really good is that he then left. Mission achieved. Mission achieved. Because a professional programmer would actually bother to actually consider why someone would spend 15 years of their life developing it, why someone would do 14,000 commits implementing it. A professional programmer would do more of a nano shred of analysis to actually work out, yeah, there could be something useful here that I could use. I could use this tool in my toolbox. So he's gone now. He might have gone and joined the Ruby community or the JavaScript community, who knows. But I'm glad because this idea of flow requires positivity. You need to be positive to be in a state of flow. You don't get into a state of flow by being negative. So that's important. The other thing about Camellia is she has the word camel embedded in her name. So she's deeply rooted as a pearl mascot. It harks back to the previous mascot. But unlike a camel, it doesn't spit and it doesn't smell. And I think that's a departure as well, a community departure. So I think that's an important idea. So I like Camellia. So flow, the idea of flow, optimised for fun, is part of the DNA of Perl 6. It's been part of the DNA of the community that's implemented Perl 6. So that's great. But what about the language itself? What is intrinsic to the actual language which can help you get into that state of flow? Well, for that we need Larry Wall, the cunning linguist behind Perl 6, to think about all the different pros and cons, all the different dimensions on which you develop a language, to try and make it work on different architectures. Because Larry's got a hard problem. He's got to solve, how do I get a computing language to run efficiently on this wetware that will scale all the way up to the HAL 9000 and all the smartphones in between? And the problem with this one is we're limited by our cavemen and cavewoman brains. We've all only got 7 plus or minus 2 chunks of short-term memory available. So we've all got about 7 plus or minus 2 bits of things we can put in our cognitive buffer. So if I gave you a telephone number of 10 digits, most of you would start looking to grab a pencil to get those last digits down. And that's just how we are. So unfortunately for us, Moore's law isn't going to save us. However, for the HAL 9000, well, Moore's law is happening all the time. So it's a tricky problem to create a language that's going to work on those different systems and work well. And flow is a psychological state which is happening over here. So if we're thinking of optimizing for flow, then we need to think about the buffer that's happening on that side. Because what I like to suggest is that optimizing for fun requires cognitive comfort. You actually want to be able to focus on your task, solving a problem with Perl 6. You don't want to necessarily have to focus on the language. You want the language to be kind of an assistant, a tool to help you. It can't tax you, or you want to tax you as little as possible. So you can just think about the problem space and your solution to it. Because for any program you're writing, there's really 3 audiences. There's your poor caveman brain that happens when you come back a week later and you look at your code and wow, what is that? And it's your own code, you only wrote a week ago. Then there's guys in your scrum team, and then there's that guy in the scrum team who insists on bringing his club to stand up, even though he's been asked not to bring it, he keeps bringing it. So you have to code for all these people. And actually, incidentally, coding for the computer, the cost of programming, the cost of maintenance, the financial costs are here. Not much cost over here. So definitely would like a tool to optimize for this. So if I come from another, just imagine for a moment you're not a Perl programmer. You've come from another language. You're a JavaScript person. You love Node, a Ruby person, etc. Somewhere along the track, you've encountered one of these. You've been flowing along in your language of choice, and then suddenly you hit a PCRA, a Perl-compatible regular expression. And, I mean, most of us are Perl programmers, I assume. For me, this stops me in my tracks. I can't read this left to right and go, oh yeah, I know what that is. I have to go, yep, and then I finally get it. So, for me, this regular expression blows my cognitive buffer. So I feel really sorry if you happen to be a programmer who's never seen a Perl-compatible regular expression before, because your buffer will be thoroughly blown. You might even have an experience like this. And I think that's, when I talk to programmers who don't know Perl and who only know other languages, there's a slight respect, but actually there's also a fear. Because at some points, they've probably encountered something like this, and felt the power, but then thought, oh no, I don't understand it. And so, I don't think this is very cool to make other programmers feel like that. I would like other programmers to feel flow, to read the code and to not be stopped in their tracks. If you were writing a computer line that caused the computer to stop, it would be game over. But they don't talk about that as far as stopping other programs in their tracks. But actually that can cost a lot of money. So, fear is a flow. Well, what does Perl 6 do for this? Well, here we have Perl 5, regular expression, so you can use Perl 5 regexes in Perl 6. And here we have regex modifiers at the start of the regex. This is just a small thing, but previously they used to be at the end, so you would read the whole thing, get to the end and go, oh, I have to read it again. So it's just little changes like this that help make things more cognitively comfortable, which I think is important. So some things to notice here is that actually white space is not significant in Perl 6, regular expressions. This is a character class with its delimiters. Yeah. So the regex I showed you earlier actually matches a version 4 IP address. And you can still use the Perl 5 version here, no problem. But here's the same thing in Perl 6. So we have it. Let's match a digit 1 to 3 times, and let's match 3 digits, or up to 3 digits, 4 times, separated by a dot.
Clear-time buffer.
Yeah. That still does my buffer too. So, what have we done to help? Well, what you can do now is, don't know why that's so big. But what you can do now is divide up a regex as you would a subroutine. So if you have a complex subroutine, you can decompose it into smaller, more understandable chunks. And likewise with the regex, you can take parts out of it and create new subparts. And subparts are sort of standalone. So for example, here is some rules to match the IP address. We've got digits. And then, so what we're saying is an IP address is actually a set of digits followed by a dot, followed by another dot. And then what we've got here is we need one, for any given digits, we can have 1 to 3, and it must be less than 256. And that is a pattern to match a version 4 IP address in .6. So, as a programmer, you would, and what you can do is you can then put these into a grammar. So a grammar kind of wraps regular expressions, named regular expressions, and acts as kind of a namespace, like a module is to a class, a grammar is to a regex. So, like a module is to a subroutine, a grammar is to a regex. So here we have a grammar that says an IP address, version 4 IP address looks like this, where the digits are here. So a bit more declarative than what we had before. And then when you use it, you could use it like this. Pull that regex in, IP address, and then, for example, if we wanted to parse this string looking for IP addresses, we could comb using that regex to extract the IPs out of it. So this is much more readable than that first regex. It's also reusable. We can reuse the idea of what we think a version 4 IP address is throughout the code. So for me, that's not blowing my buffer. And the previous grammar slide, that didn't blow my buffer either. But it's one of these things, it's a learning thing. So of course there's version 6 IP addresses as well. And here at Rosetta Code, you can see the full grammar for version 6 and version 4 IP addresses. So what's Rosetta Code? Well, Rosetta Code is the A to Z of, it has an A to Z of languages, different solutions in different languages to hundreds of different programming problems. And actually this is where Larry Wall has spent quite a bit of time during the development of .6. And it was suggested, why is Larry in here doing that? And I can't think of a better place for the language designer to be. To have to solve different problems next to other languages solving the exact same problem. It's a really good way to test the language, to test its semantics, to test its ability to solve problems. So if you've not had a chance to look at the Perl 6 examples on Rosetta Code, take a chance to look. And just have a look at the expressivity of Perl 6 versus the other languages you see there. And I think it's quite clear what's going on with Perl 6. Because as far as I can tell, Larry Wall, of all the different dimensions that you can turn up on language design, functional versus not functional, OO versus structured, in all those different language dimensions, there's two particular dimensions that I think he's really turned up, both. Whip amplitude and expressivity. So, what do I mean by whip amplitude? Well, this is Hello World in Java. And I used to teach Java at university, and I give this example. And I always found it actually quite hard to teach, because students would quite fairly ask, why, if the function is just printing hello world, why do we have to have parameters coming into it? And I'd say, yeah, I know, but you just do. And, why is it static? why does the file name have to be the exact same case as the class name? Yeah. So, with Buppertube is all about having a low on-ramp so that you can do something quickly and understandably without having to overcome some sort of initial barriers to entry. And then ideally have it, as your knowledge of the problem space increases, that actually your solution increases as well. So this is Hello World in Perl 6. And because strings are objects, you can also say a string. I'd much rather be teaching that. Next year. Let's hope. Okay, let's say you've got a job to do. Right, you need to write a new deployment script. And okay, what we need to do is deploy to nodes of a given node. So here's a little bit of Perl 6. Sub main, node name, and it's just going to say deployment. Well, Perl 6 will with this main method, it'll automatically give you a help usage for it. So this all comes for free, and now you can deploy to your node. So easy to get started. Then your boss comes along and says, well, actually, what we need to do is we need to deploy to a given IP address, not just the node name. It's actually lost track of their nodes now. We just have the IP address. So here what we can do is declare a multi-site, where we're going to add another name method, which, given a node IP address, which has a type constraint that, well, it needs to match the IP address version 4 regular expression, that we don't need to be writing that massive regex in there, which will then deploy this IP address. So multi-dispatch, it will choose the right option. So that's with Buppertube. And you can imagine then later, other things could be added to this script, more methods. It might then get broken out into a module. Okay, so there's a clear path for the solution to follow the problems. So the other way that I think Larry Wall's really turned it up to 11 is through expressivity. So the language is really expressive. When you look at Rosetta Code solutions, it's often the case that the Perl 6 one is shorter. There's less lines of code than the other languages. So here is a factorial function in Perl 6. In Perl 5. And it's like an iterative way of working out factorial. You might have been in a job interview and someone slid the notepad across the desk to say, write the factorial function. So here's how this would look in Perl 6. You could have done it iteratively, recursively, declaratively, but here's a flavor that's expressive. It's saying, well, let's create a postfix operator, exclamation mark, like it is in mathematics. And what we'll do is we'll take the first parameter and we'll do a range from 1 to what gets placed in, and then we'll multiply all of the elements in the range, which prints 120. So that is how you would do, one way is that you can do factorial in Perl 6. So it's a really expressive way of solving that problem. So what are those brackets doing? What are they doing? They are actually meta operators. So operators on other operators. And that's the reduction meta operator. So what's it doing over here? Well, so here we have a list of numbers from 1 to 3. So what does that do? What's the answer?
6.
6.
That's
Yeah, that's right. And then what would that one be? Yeah. This one?
1.
This one?
1, 2, 3. 1, 2, 3.
Yeah. 1, 2, 3. So this guy here is the string concatenation operator. And you can think of it as like a string weaving strings together. So it's a really good visual way of remembering what that operator does. It's a nice mnemonic, so you don't have to use too much brain space. What is that?
3.
And the other thing about it is, you know, in JavaScript and things, when you have the plus as the concatenation operator, like string concatenation, you then have to think about like numeric and other things. What are the things I'm adding there? Whereas here, the operator is clear. Okay, what do you think this would be?
False.
False. Because it's sort of, okay, so what's happening is that you can imagine the operator being put in between each element in the list. And then this would be true, and this one would be
True.
well, it's been reversed. So this list would be reversed to be 3, 2, 1, and then 3 would be greater than 2, which is true, and 2 would be greater than 1, so the whole thing would be true. So that's just a little example of kind of the expressivity of the language. Like taking operators and then saying, well, actually, I just want to apply that operator to the whole list. How can I do that? Okay, I'll put it in that sort of sliding window. I'll reduce that list using the sliding window. Here's another meta operator. This is just going to do the cross product. So it's going to join everything in one list with everything in the other list. So if we wanted to create a deck of cards, we have all the suits. So we can put Unicode into the source. And we have some ranks. And then to generate a deck of cards, what we could do is we could take the ranks and join them with all of the suits, concatenating them together. And it would be easy then to pick a random 5 out of the deck, and this would give us a hand of cards.
Good.
Yeah. Should have done that one. Okay. So here's another problem. Okay, say you're a lean programmer, which means you want to do as little as possible and get maximum results. Boss comes and says, I need dates for all the last Fridays of the month for this year. So really, I think this is fair play. Lean programmer says, you know what, I don't need a computer for that. There you go, boss. Go away now. Problem solved. But then boss says, oh, I want it to last all the last 20 years. So it's at that moment that, okay, get the computer out, open up a terminal, and type. Now, if Python was your thing, you'd be off on a 14-line of code thing to try and solve that problem. If you chose an iterative solution. And if you look at this example's on Rosetta code, you can see the other languages, and you can sort of just compare side by side. The Java one is 16, 17 lines of code. So here's last Friday until 6. So 7 lines of code. Because we're using this the sub-main, we automatically get this help text for free. So to compute the last Friday, what we're going to need is a parameter for year. It takes an int. And given that, we work out the last Fridays for the year. So I've truncated the output here, but you would actually see all the last Fridays. And so reading this code, it's saying sub-main routine. We're going to take a named parameter of type int, which is a year. will default that year to today. Today's year. And then iterating through all the days, starting at the start of the year to the end of the year. If the day of the week happens to be 5, then that one's going to be a Friday, and we can add that to this list, which means the last Friday for a given month is going to overwrite the previous Fridays of that month. So in the end, we'll be left with the last Fridays for the year. So for me, this is almost behind my buffer, but not really. It's okay, I can do that, and I can kind of understand that. And I hope that you guys can also see that. That's a fairly understandable thing. So it's an expressive answer to that problem. So they're just a couple of really small examples of whip-uppitude and expressivity that I've just borrowed from Rosetta Code. There's tons, hundreds more on Rosetta Code. Have a look and just make an assessment between the different languages that you might use, and just see what PL6, how PL6 solves the problem. I should mention there is another. I had a look again on Rosetta Code a couple of days ago, and there is a new submission here, and there's an even shorter version. It's like 3 or 4 lines. So, as always, there's more than one way to do it. Okay, so I hope that I've encouraged you to go and look at PL6 if you haven't already, to open it for Christmas and see if you can find flow with it. The thing is that at Christmas, maybe people from other programming languages will be looking at what's going on with this. So you can imagine benchmarks. I just tried this in PL6, it took this much time. It's crap. But actually the language hasn't been optimized, fully optimized here yet. It's been somewhat optimized, but there's more to do with this side. But a lot of it is involving what's going on here. And that's what I think is the joy of 6. So this ability to find flow with the language, to basically solve your problems quickly, make progress, and improve. Okay.